NASA is on the hunt for Dyson Spheres. Turns out there are 60 stars that give off weird light patterns. This means there might be some extraterrestrial technology nearby. A team of scientists has developed a new way to search for advanced civilizations by looking for Dyson Spheres. All forms of life, from microbes to us, need energy in order to survive. As living creatures keep evolving, their energy needs grow. We started with small fires, then moved on to coal, oil, and eventually solar panels. Now imagine a super advanced civilization that has used up all the energy sources on its planet. What's next? Their host star, an almost limitless power source. This is where the idea of Dyson Spheres comes in. It was made up by the physicist Freeman Dyson in the 1960s. This idea says that, hypothetically, we could build an incredibly big structure around a star to capture its energy, like some sort of gigantic solar panel. Advanced civilizations could use it to power their planet and even interstellar travel. Right now, something like this would be impossible for us to build, but maybe someone else in the universe has managed to pull that off. Scientists gathered lots of data from surveys of stars. They analyzed over 5 million objects and found some candidates. Of course, extraterrestrial civilizations might have completely different technology, so astronomers aren't looking for actual giant shells around stars. Instead, they're looking for technosignatures. These are weird things that might indicate the presence of something technological and can't be explained by known natural sources like galaxies or nebula. For example, a structure like a Dyson sphere could give off unusual infrared radiation. This is because, while absorbing a star's energy, this structure would give off crazy amounts of heat. Out of millions, they identified 368 potential candidates. Further filtering left them with only 7 objects that could be Dyson spheres. Now usually, weird infrared flickering happens from giant crashes in space, like planetary collisions. Warmed up dust and rocks get scattered around and give off strange lighting patterns. These are called extreme debris disks. The researchers think these 7 objects could be M-type stars, also called red dwarfs. These are stars that are very small on a space scale and a bit fainter than our Sun, a yellow dwarf. Stars like that don't usually have warm dust and rocks around them, but scientists need to do more tests, like looking at the light in detail, to be sure about their discovery. There was another study that found 53 star candidates with similar excess infrared radiation. But these also need to be checked. Scientists plan to use advanced tools like the James Webb Space Telescope to take a closer look at all these candidates. One famous candidate is Tabby's star. Scientists even made a joking name for it, because the paper about this star had the subtitle, "Where's the flux?" Think of an acronym yourself. Now, it's a bit hotter and more massive than our Sun. It's caught NASA's attention because of its unusual, irregular light dimming. For some reason, it doesn't glow like a normal star, but blinks, as if someone turns on and off a flashlight. At first, you might think this is just because some big planet is passing in front of it, or a comet, but we're talking up to a 22% drop in light. No planet could manage to eclipse a quarter of a star, and that's where the name comes in. So, another explanation is a Dyson sphere or some similar megastructure. Someone also suggested that the dips might be caused by fragments from a broken exomoon orbiting the star. There are other stars that show similar traits, but there's no solid evidence to support this. So for now, scientists just don't know. So astronomers are on the hunt for any giant structures. There are many variations of what a Dyson sphere could look like: rings, bubbles, a swarm of satellites, a giant shell, and so on. A Dyson shell would be a solid, rigid shell completely enclosing the star. This is the most extreme option, the hardest one to build. Also, if other civilizations built that thing, it would fully cover the star's light, and we simply wouldn't see it. The inner surface of this shell could be lined with habitats, and we could simulate gravity by rotating the structure around the Sun. A Dyson swarm is the simplest option, a bunch of solar-collecting satellites and habitats orbiting the star. It would be a lovely place, with people living in many space stations or mini space houses within the swarm. Each little habitat would have its own air, life support systems, and artificial gravity. We could also grow our little farms there. And imagine the view. We would see a constant bright sky with other habitats visible across the expanse. A near unlimited energy of a star would mean we could advance our technology very fast, manufacture tons of materials, and terraform planets within the star system. But building and maintaining a Dyson sphere would require advanced robotics, AI, and tons of money. It would take us centuries or millennia to get there. Now, giant megastructures aren't the only things that scientists are looking for in order to find extraterrestrial life. They also look at the planets. Now, planets must have certain characteristics to be potential homes. There should be liquid water and an energy source, something to drive these reactions, creating the building blocks of life. Turns out such conditions aren't rare at all. Our search showed that there might be more than 60 billion potential habitable planets in the Milky Way alone. Unfortunately, we can't look at them directly or land there. So we have to use tricks, like detecting water and good gases in their atmosphere. Recently, the James Webb Space Telescope found possible signs of life on a planet called K218b, which is pretty close, about 120 light-years from Earth. This planet is 9 times the size of Earth. It has clouds of liquid water but a different atmosphere, full of gases like methane, carbon dioxide, and dimethyl sulfide. Regular oxygen-breathing life wouldn't do well at all there, but on Earth, dimethyl sulfide is produced by life forms like phytoplankton. They also discovered that weird wiggly planets could be signs of advanced extraterrestrial civilizations. In our solar system, each planet has its own orbit. But the universe likes to surprise us. Surprise! Models show that there might be planets that share the same orbit. For example, it's possible if the planets are evenly spaced around the star, minimizing their gravitational impact on each other. Or the so-called horseshoe configuration, when planets speed up and slow down in relation to each other, moving in funny wiggly ways. These horseshoe systems can hold up to 24 planets. This is one of those things that are possible, but very unlikely without some help. Normally, gravity would immediately destabilize such systems. This means that if we ever find a star system with 24 planets sharing orbits, it might indicate that some advanced civilization decided to lend a hand. They also might contact us themselves. The search for extraterrestrial intelligence began in the 1960s when astronomer Frank Drake started listening for radio signals from space. Today, they persist. Astronomers listen for leakage radiation from other civilizations, which are radio waves unintentionally sent into space from everyday activities. Recently, they detected radio waves from YZ Ceti b, a planet super close to us, just 12 light-years away. This means it might have a magnetic field, invisible shields that are very important for protecting life from the solar radiation. But YZ Ceti b is probably too close to its star to be habitable. But there are a lot of places for such a signal to come from. It turns out there are 1,000 star systems in our galaxy where they can see us in the sky. All these stars have a perfect view of Earth passing in front of the Sun, making it easy for potential extraterrestrial astronomers to spot us. So, there are over 1,000 star systems that could be watching us right now. And if we study them, we might one day find evidence of intelligent life looking back at us. Hello!
Don't hold your breath, but we're very close to hitting a major milestone in human history. Some scientists say the next couple of centuries will be a make or break situation for us. Will we be a measly Type 0 civilization forever? Or will we blast off into the stars like the boss-level beings we are? Don't know what a Type 0 civilization is? Let me explain. As our species gets bigger and smarter, our energy needs go through the roof. And that's not just because we all want to keep our hair dryers running, but also because all our fancy machines need energy too. Our transportation devices, factories, and communication tools. The Kardashev scale is useful in measuring how advanced a civilization is, based on how much energy they've got. So far, there are 7 theoretical levels a civilization can be at, according to most specialists. I'll spare you the Google search. Some scientists have estimated that humans are at a mere level of 0.72. We're not even a Type 1 yet? The scale was invented by a scientist named Nikolai Kardashev in 1964. He created it to help look for signs of life in space through the signals it might give off. His scale has 3 main levels that show the amount of energy a civilization has access to. Over the years, other scientists added many more levels, which are even more advanced. This scale not only shows energy access, but also how much knowledge a civilization has. A Type 1 designation is when a species can gather and store all the energy from a nearby star to power its growing population. This means we need to increase our energy production 100,000 times to reach this status. Some scientists say we could reach Type 1 in 100 to 200 years. But for that, we would need to harness all the energy on Earth. It sounds amazing, but compared to what advanced societies with higher rankings can do, this is just a basic level of control. The next level of civilization is called Type 2. They can control their whole nearby star and use all of its energy. One way we might be able to do this one day is by building something called a Dyson Sphere. I'll spare you the technical details, but it's like a giant ball that goes around a star and collects all its energy, then sends it back to the planet it came from. With this much energy, nothing in science could destroy a Type 2 civilization. If humans became a Type 2 and a moon-sized object was headed toward Earth, we could just vaporize it, or even move Jupiter to block it. Type 3 civilizations become energy experts and can travel through the galaxy. Humans who evolve into this type may look very different from us, like machines with both biological and robotic parts. They might even look down on regular humans. Who knows? It's unlikely you'll make friends with a Type 3 person, that's what I'm saying. These humans might also have colonies of robots that can replicate and spread across the galaxy. But there are limits to their travel because of the laws of physics, or at least those that we know today. That is, unless they invent a new way to travel faster than light or teleport through wormholes, which are currently only theories. Kardashev believed that a Type 4 civilization could not exist. That's the reason why he did not go beyond a Type 3 on his original scale. He thought Type 3 was the limit any species could achieve. Some people agree with him, but others think there could be even higher levels of civilization. Type 4 civilizations and up were theoreticized by other scientists. A Type 4, for instance, would be able to harness all the energy in the universe and even live inside black holes. This kind of technology would need to use laws of physics that we don't understand yet and might not even have the resources to discover at this point. Type 5 is even more mind-boggling. This would be a level where beings have the power to control the universe itself. It would also exist in a world with multiple parallel universes. Humans are far from ever reaching this level, but if we take care of our planet and each other, who's to say it can't be possible one day? These types of civilizations would have the ability to travel to different universes and even be able to create our own. They have control over reality, and their population would be so large, it would be, in theory at least, indestructible. A Type 6 civilization is even more powerful. They would have the means not only to create and travel to other universes, but also to control the basic functioning rules of these worlds. They would exist in a lot of different universes at the same time, and they could affect all the laws of physics as we know them. They also exist in many different versions of space and time, with different pasts and futures. A civilization that is categorized as a Type 7 or K7 is capable of traveling and controlling the entire omniverse. The omniverse is a term that refers to every universe, dimension, and reality that exists. This level of power is thought to come from an individual rather than a civilization, as the civilization would have merged into one entity that is all-knowing, all-powerful, and present everywhere. Okay, let's slow down for a bit. Before we reach all these incredible levels, we at least need to become level 1, right? But what would that take? Right now, humans are not advanced enough to be considered a Type 1 civilization because we only use a few sources of energy, like wood, coal, and oil. But there are many other sources out there that we haven't discovered or used yet. We'd need to rely solely on renewable sources, like wind, sun, and water for our energy needs. This energy would be so accessible that you might not have to pay for your power bill anymore. In a Type 1 civilization, energy would be as essential as air. One strategy would be for us to turn natural disasters into something positive. For example, we can use tsunamis to make electricity. We could rely less on construction work and use earthquakes to help us change the land. By controlling the planet's energy sources, we could also control the weather. For instance, if a certain place would be experiencing a drought, we could just send rain clouds to bring it back to life. If we become a Type 1 civilization, we might be able to balance the amount of carbon in the atmosphere and end up controlling our planet's temperature. This means that natural disasters will become easier to predict and less damaging. Additionally, we might even be able to live in places we never thought possible, like underwater, on top of mountains where it's freezing, or in the desert. So how close are we to this level upgrade? A recent study looked at the different ways we get energy, like from fossil fuels and renewable sources. Problem is that each way of getting energy has its limitations. For some, we have limited materials. For others, at least for the time being, the costs are too high. So the team behind this study took a careful approach to make precise calculations. They found that we can reach a high energy level, but it won't happen until the year 2371. This study shows just one way we can become an advanced civilization, but it's also possible that we'll get there in a completely different way. Also, let's not forget, the first rule in becoming an advanced technology is to not become extinct. I know that sounds a bit redundant, but in our quest to harness all the energy this planet has to offer, we also need to protect it to the best of our abilities. Until we manage to travel to the edges of the universe, Earth is still the only place we call home.
Now, let's think for a moment. What if, instead of building spaceships to move across the stars, a super advanced civilization decided to turn their entire star system into a spaceship? That means a whole sun, the planets, all the asteroids, zooming through the galaxy together. That's what one philosopher, Clement Vidal, suggested in his recent space theory. There could be countless reasons why these extraterrestrials might decide to explore space. Maybe the star nearby is about to go supernova, blowing up and destroying everything nearby, including their home system. Or maybe they're searching for new resources somewhere in outer space or trying to spread life. But our galaxy has a minor problem. It's incredibly huge. So even if they move with the speed of light, getting from one star to another would take a gazillion years. Ooh. However, if we could just move our entire solar system, that would be convenient. We wouldn't have to change a thing or look for another star system and planet. How, though? Well, they'd use their own star as an engine. Literally, a stellar engine. All they'd need to do is push their star and everything orbiting it in a specific direction. You must cause the star to spit out material unevenly, creating a kind of thrust. It's like our rocket propulsion, but applied to entire stars. When more material ejects on one side of the star than the other, it acts like a rocket, slowly nudging the entire system along. Over time, they could steer it to wherever they want. Now, this isn't just some goofy idea, well, maybe, but many scientists have proposed different models for how a stellar engine could work, and how we humans could use it. The most famous one is called the Shikhatov thruster. Here, the idea is to use a giant reflective mirror to push a star gently in one direction by reflecting its sunlight. Other designs propose ejecting mass from the star itself. Of course, that'd be insanely hard for humans to pull off, but a super advanced civilization might just do it. And it might not be as hard as it sounds. There are already stars in the galaxy that move at incredible speeds. They're called hypervelocity stars. These stars are so fast they can escape the galaxy itself. Their story begins in the heart of the Milky Way. At the center of our galaxy lies a monster, a supermassive black hole with gravity so intense nothing can return from it. We even took a shot of it a while ago. Remember this one? It's called Sagittarius A star. We start with a pair of binary stars. They are similar in mass and orbit each other. Sometimes they stray too close to a black hole. When this happens, one star can get captured by the black hole, its fate sealed, while the other gets the wildest roller coaster ride of its life. It's like a crazy slingshot. It's hurled outward with unimaginable force. These exiled stars gain incredible speeds, like over 1,000,000 miles per hour, and become hypervelocity stars. Now, this doesn't happen that often. Maybe one hypervelocity star is flung from the galactic center every 100,000 years. And with over 100 billion stars in our Milky Way, finding them is worse than needles in a haystack. But even so, we managed to find about 1,000 such exiles in our galaxy. But anyway, could these superfast travelers be extraterrestrial starships? Maybe it's some wild move other civilizations decided to pull off, getting slingshot by a black hole so they could travel wherever they want at wild speeds. Now, most hypervelocity stars studied so far are single stars. But what about binary systems themselves? This binary system we mentioned would make this whole process of turning a star into a spaceship much easier. Another civilization could focus their efforts on one star in the pair. The interaction between the two stars could be used to fine-tune direction and spin, like a built-in steering wheel. It would also help use energy more efficiently. Let's try implementing this. Take a neutron star. This is what's left behind after a huge star reaches its end. Its tiny, incredibly dense version. These little neutron stars are often paired with the small and normal ones. Neutron stars have some insane gravity. This could help them provide the energy needed to push the whole system. So, if an extraterrestrial civilization decided to build a machine like this, they'd probably do that near a binary system like this. But would our extraterrestrial friends settle for basic binary systems? Actually, they could go even further, for a wilder, more efficient option – Black Widow pulsars. Ooh. This is the most dramatic type of a binary system. A neutron star spins with unbelievable speed and doesn't just hang out with its companion star, but slowly devours it. These two create such a thrilling gravitational dance, it's both destructive and beautiful. As the neutron star spins, it just keeps flinging torrents of high-energy particles right into space, and all of them clash with the fragile remnants of its poor little partner. Can you imagine that this energy could be harvested? All these options – hypervelocity stars, binary systems, and spider pulsars – would be great for this stellar engine project. A civilization that had this type of engine could gradually explore and colonize the galaxy, all while having its own energy source and planets with them. But how do we know whether these starships actually exist? Astronomers look for something called technosignatures. These are little clues and hints, something that looks unusual for normal celestial bodies. For example, things like weird motion in binary systems, or stars that eject material in weird, unnatural ways. They could all mean that there's some technology being used there. We haven't any evidence of that so far, but there are candidates. There are 2 Black Widow pulsars that look strange. Clement Vidal, the author of the paper, says that we should look at those systems closely, just in case. And even if it turns out that this idea is incorrect, we can still use it as an inspiration for ourselves. If extraterrestrial civilizations won't do this before us, we might just pioneer that technology. And speaking of techno-signatures, besides these starships, NASA is also looking for signs of megastructures in space. Maybe other civilizations don't treat their stars as some sort of chariot horses, but simply use them as a giant energy source. Life needs energy to survive, whether it's microbes, animals, or smart human-like civilizations. As life evolves, its energy demands skyrocket. Now, we started with fire, then moved to coal and oil, and now we're exploring solar power. One day, we might start harvesting the power of our sun directly. Maybe advanced extraterrestrial creatures are already doing this. On Earth, a physicist, Freeman Dyson, proposed the idea of a Dyson Sphere, a huge structure around a star that can harvest its energy, like one enormous solar panel, but right around the sun. Sounds crazy to us, but we might find it somewhere out there. Once again, astronomers are checking techno-signatures to spot those. For example, they've analyzed data from over 5 million stars, trying to find weird signals, flickering, or anything that can't be explained by dust or similar stuff. If we're talking about a Dyson Sphere, then eating a star's energy would make it radiate a lot of infrared heat. That means we'd notice a telltale glow. Eventually, they narrowed it down to 368 possible suspects. They checked those, and only 7 stars remained. These stars show strange light patterns that we really can't explain yet. These stars are mostly small, faint red dwarfs. One of them is especially famous, called Tabby Star. It blinks and dims in weird random ways, dropping in light by 22% from time to time. Astronomers aren't sure whether it's some broken moon flying around it, dust, or a Dyson Sphere. In any case, they'll keep looking for these techno-clues. Let's hope we'll learn the truth someday. So how alone are we in our galaxy? Crickets. Yep, we're mostly alone out here. But are there other civilizations lurking somewhere out there in the depths of the Milky Way? Could they possibly have evil intentions and be a threat to us? Hey, like we need more threats. Well, hey, let's have some fun with this. Some theorists reviewed humans' history and past actions toward one another. No miscongeniality awards there. And assuming they were somehow like us, used this to calculate the probability of space invaders. They determined that there could be 4 evil civilizations in our galaxy. The 4 could be eager for intergalactic domination, or maybe just for a good game of dominoes. They could be highly advanced in technology, or they've only just invented an evil version of game consoles. To understand how advanced these cultures could be and what to expect, there is a way to define their threat levels. A method called the Kardashev scale analyzes intergalactic nations' possible abilities. With 3 different levels, it reviews the amount of energy a civilization could take from their star, indicating their tech level. This only includes those that have reached interstellar communication. So any other beings out there using, let's say, space pigeons will of course be excluded. Type 1 shows that they can harness the energy from the sun, but only from what is received within their own planet, like solar power panels. Type 2 is where they can use the energy directly from the sun, like through a Dyson Sphere. It's used to harness all of the sun's energy, having been built entirely around it. And lastly, Type 3, where civilization can use all elements provided by the galaxy, with the power to not only harness the energy from stars, but also black holes, even the central supermassive one. These levels are important to assess how advanced civilizations could be out there. The Milky Way is estimated to be around 13.6 billion years old. Modern humans have only been around for the last 200,000 years, and we're only a type 1. It's scary to imagine the time other beings have had to develop. We're considered a bit of a late bloomer in comparison. Earth is, shall we say, late to the party because we're located on the outer arms of the galaxy. Mathematicians posit that more centralized star systems have had more time to progress. Now, with that in mind, how common would other intelligent beings be in the galaxy? With all the life-ending events Earth has survived, it's a miracle to have a planet like ours, and that we would be unique. Or are we? Well, there are 100 trillion stars in our galaxy, and there are up to 200 billion planets, with an estimated 300,000 exoplanets capable of sustaining the kind of life we know about. From those habitable planets, how could we tell which ones have other beings eager to send us an email? No one's had the time to individually count, of course. The Drake equation can give us some rough numbers if we take averages of a few key factors. It breaks down the criteria of how many planets with life are intelligent enough to make communication. The numbers are huge, considering how many stars might have planets. And from there, we distill it down further to those within the habitable zone in the solar system. This zone is called the Goldilocks zone, as it's not too far from the sun and not too close to it. It's just right. We reduce the numbers even further by calculating which of those habitable planets will then be able to support life. And from those random places, the equation takes the probability of how many intelligent beings will be and if they are intelligent enough to communicate. The criteria is complicated, and so it's not an easy equation to explain. But from its estimate, there could be up to 100 million planets with intelligent civilizations. But just like with Earth history or struggles, these civilizations may also have their own challenges. World-ending events should be thrown into the equation, like asteroids, solar flares, supervolcanoes, and supernova. They could also destroy themselves through technology, like AI dominance or nanotech, or by affecting their own ecosystems and running out of resources, or by just acting stupidly. If we take these into the equation, the remaining living civilizations could be around 15,000. But what could they possibly want from humans? We do have an abundance of rare earth materials that could be of value, ready to be harvested and easily collected. Besides an appealing vast amount of water they could suck dry, hydrogen is a required element of rocket fuels. Though these things aren't exactly rare in the galaxy and could be harvested easier from other closer solar systems or asteroids. Our technology might be intriguing to them. Our range of innovations on Earth, invented while being isolated in separate countries, help provide different technology paths around the world. Other civilizations could have followed a completely different route, and didn't learn the importance of many things we have here on Earth, like karaoke. The same goes for applied sciences, where they may have evolved in different atmospheres with different elements. Their science would be mainly affected by that, and ours would provide them with more knowledge. Then, there's one of the rarest things in the galaxy, that Earth can support life. This would be very useful for an intergalactic traveler, rather than going through the long process of terraforming an unlivable planet. Why not just take it? With a cozy outpost, it would be a lovely little holiday destination when they need some time off from conquering other civilizations. Fortunately, they wouldn't be interested in eating us, or probably wouldn't have an appetite for anything on Earth. They would need to have similar biochemistry and require the same enzymes to process the molecules we're built from. Whew! But the most likely thing they would want is to remove any competition. The biggest threat to them is anything that would provide a challenge to their domination. But before you get too frightened by these evil civilizations, this was based on human behavior. It's possible that any beings out there could lack or avoid many of our human emotions. For instance, their capacity for anger might be limited, or they could have evolved without it. They could come from a world with a history so different from ours that they could be overly trusting, making us the bad guys. But again, They may also lack empathy and other positive traits we have. Well, let's hope they only have our nice traits. Luckily, there's a big thing that separates us from everything else. The galaxy is huge, and it takes a very long time to go anywhere, even to our closest solar systems. The fastest thing we've sent into space is the Galileo probe, which travels up to 100,000 miles per hour. Even so, it would take 72,000 years to reach the closest star system, Alpha Centauri. Still, with a newly proposed laser-guided probe that could travel at 1/5 the speed of light, it would yet take up to 20 years to make that journey. On a larger scale, the Milky Way is over 105,700 light-years across. If a civilization was even capable of light speed, it would take them hundreds of thousands of years to travel from one end to the other. With a huge distance between the small number of civilizations, the only successful contact would be through advanced interstellar travel. But to achieve such a long journey, the greater the mass to be accelerated, the more energy is required, so it's not likely anything too large will be sent. But they could travel here very quickly in a small shuttle, using the ability to break cosmic speed laws. They may already be here, watching us closely, or just binge-watching Netflix. They would need very advanced technology, and the number of species obtaining this is theorized to be only 2 out of the 15,000. That means there's a 1/100% chance of evil civilizations capable of visiting us soon. If they do know we're here, and they want something from us, it's likely to take them thousands, if not millions of years to arrive. So, we've got plenty of time to relax. Time for more bright side.
We just found the biggest clue ever that someone lived on Mars. Or should I say, something. Because if you're picturing skinny red extraterrestrials with big goofy eyes, forget it. The Martians we're talking about looked more like this. A tiny microbe. I know, a total bummer. But this could change everything. See that weird pattern on the rock? The one that looks like leopard spots? Experts think it was left behind by ancient life. And no, it's not like someone painted it, the way early humans drew on cave walls. These little marks could actually be leftovers from microbes. Signs that some pretty wild chemical reactions were happening back when they were formed. And don't worry, we'll get to that in just a second. So NASA actually found this evidence over a year ago, and they were thrilled, as this was exactly the kind of weird rock they'd been hoping to see on Mars. They thought this weird pattern might be a biosignature. In other words, a clue that life was once there. That could mean an element, a molecule, some substance, or in this case, a funky leopard print pattern on a rock. But scientists were cautious back then. After all, you can't just go around shouting, "We found life on Mars," without being absolutely sure. It could have just been, well, a cool-looking Martian rock, right? So, they studied this sample again and again. And by they, I mean more than 1,000 scientists from NASA and partner institutions all over the world. And recently, they finally came out with a paper that basically says, listen, we can't find another explanation. And that's it. With no other explanation left, this might just be the best evidence we've ever had that something really did live on Mars. The sample, nicknamed Sapphire Canyon, was collected by the Perseverance rover in July 2024. It was taken from rocky cliffs along the edges of the Neretva Vallis River Valley, a region shaped long ago by water that once flowed into Jezero Crater. And we're talking like more than 3 billion years ago. Scientists believe that back then, Neretva Vallis was filled with rushing rivers carrying mud, sand, and gravel into the lake. When the water eventually dried up, it left behind the rocky outcrop where Sapphire Canyon was found. After collecting the sample, the Perseverance rover kept exploring the river valley to get a better idea of the environment where those rocks formed, and to figure out how those leopard spots might have appeared. That step matters because knowing exactly how the spots came to be is key to figuring out if the rock really holds signs of life. In other words, Did those patterns form through normal chemical processes that don't need life at all? Or were they actually left behind by microbes? What the rover's instruments found is that the rocks in this area are made of clay and silt, which is exciting, because here on Earth, those materials are great at preserving signs of ancient microbial life. The rocks are also packed with organic carbon, sulfur, oxidized iron, and phosphorus. And you know who loves that stuff? Microbes. Experts think they could have used those ingredients as an energy source, and in the process, left behind the leopard spots we can now see in high-resolution images. Remember when I said these marks might be a microbe's leftovers, right? That's exactly it. Picture you're eating a burger called the Galaxy Burger that has a one-of-a-kind sauce. A drop of that sauce falls on the table. You don't clean it up, and a second later, poof, you disappear. Later, detectives show up trying to figure out if you were there. All they find is that sauce drop you left over. From that, they can tell exactly what you were eating: the Galaxy Burger. But proving you were really there is tricky, since that sauce could have ended up there in lots of other ways. The same goes for the leopard spots. Just by looking at them, scientists can already tell a few things. For example, the pattern shows the presence of two iron-rich minerals, vivianite and greigite. On Earth, vivianite often turns up in sediments near decaying organic matter, or in swampy, soggy wetlands. In a similar way, microbes can also produce greigite on our planet. When you find those two together, it looks like they formed through electron transfer reactions between the sediment and organic matter. That could be a fingerprint of microbial life, because microbes use those reactions to get energy and grow. So, going back to our burger comparison, the leopard spots are like the sauce on the table, the leftovers from the process of getting energy. But that's not the only theory. The team also spotted the possible presence of hematite in the rock. And if Mars has the nickname the Red Planet, hematite is the one to blame. It's a heavy mineral that can take on a reddish tone. On Earth, people have been using it as a pigment for paint for thousands of years. Now, scientists think the leopard spots may have formed when chemical reactions with hematite turned parts of the rock from red to white. That process can release iron and phosphate and possibly cause those black rings to appear. And here's the kicker. Those reactions can also provide an energy source for microbes. For now, though, these are just theories. What we can confirm is that those chemical compounds are definitely present in the rocks. But just like in the detective story, finding the sauce drop doesn't prove it came from you. So even though these materials are great for microbes to thrive on, it doesn't automatically mean this is a biosignature. They could have also formed abiotically, or, put simply, without the presence of life. Yeah, it could happen, but for it to happen naturally, without microbes involved, you'd need two things: high temperatures and acidic conditions. That's the only way those chemical processes could do their magic and leave behind the leopard spots. And here's the exciting part. Scientists didn't find any sign that these Martian rocks were ever exposed to high heat or acidic conditions. That's why I said they're stumped. They just can't find another explanation. So this has to be a biosignature, right? Well, maybe not. Because there's still a possibility that organic compounds could react even under low temperatures. And maybe, just maybe, we're seeing that happening for the very first time. That's why it's so hard to confirm 100% whether this is the handiwork of ancient microbes or just a natural process. So, in the end, we're still left with more questions than answers. Right now, this precious sample is safely sealed inside a tube millions of miles away on Mars. Hopefully, one day, it'll be brought back to Earth so scientists can study it in labs here. And while we can't confirm it's a biosignature just yet, one thing is certain. This finding by Perseverance is the closest we've ever come to discovering life on Mars. Honestly, just being able to spot a potential biosignature on the red planet is already groundbreaking. Another reason this finding matters has to do with the age of the rock. This evidence comes from some of the youngest sedimentary rocks we've ever studied. Until now, scientists thought that if we ever found signs of ancient life on Mars, they'd most likely be locked inside much older rocks. But so far, nothing has shown up in those ancient formations. Finding a possible biosignature in a young rock suggests two things. First, Mars might have been habitable for longer or later in its history than we ever thought. And second, older rocks might also hold signs of life, but maybe they're just harder to spot. Someday, our technology could be advanced enough to find them. This discovery also makes us think about one of the biggest questions of all, and that is, are we truly alone in the universe, or did we just find the answer? No, not exactly, but it's the closest humanity has ever come to answering that question.
Now, it's been a long time since there was a supernova in the Milky Way, over 400 years to be precise. So hey, we're long overdue. So here are the most likely stars to go boom, if they haven't already. At the top of the list must be the Southern Hemisphere star Eta Carinae. Greek letters before the name of the constellation indicate the rank of the star's brightness in that constellation. Sir Edmund Halley, in 1677, recorded Eta Carinae as the seventh brightest star in the constellation Carina, Eta being the seventh letter in the Greek alphabet. It might not have looked very bright to Sir Edmund and his contemporaries in the 17th century, but modern studies of Eta Carinae estimate it's 5 million times more luminous than our Sun. Luminous is a technical word astronomers use. It doesn't just mean brightness. Luminosity refers to the total energy released at all frequencies. Eta Carinae releases 5 million times more energy than the Sun. Truly one of the whoppers of the Milky Way, Eta Carinae is 100 times more massive and 240 times larger than our yellow-white dwarf sun, Sol. Obviously, since it appears dim, Eta Carinae is pretty far away, about 7,500 light-years away. Yet even at this distance, if this star goes hypernova, it can still impact Earth's ozone layer, disrupt satellite communications, and harm astronauts. 159 years after Halley's observation, Eta Carinae experienced a nova-like explosion. It increased from a relatively dim star to become the second brightest star visible from Earth, but only for a period of 27 years. From 1836 until 1863, Eta Carinae was the second brightest visible star after Sirius, the dog star, and Sirius is only about 8 light-years away. Since 1863, aside from a couple of flare-ups, Eta Carinae has dimmed back down to its original brightness at magnitude 4.5. Now, astronomers owe us a small apology, which we don't expect to get anytime soon, for star magnitude nomenclature. The brighter a star is, or planet, or moon, the lower its magnitude. Thus, stars brighter than first magnitude are either zero magnitude or negative magnitude. The full moon, for example, is magnitude negative 13. A magnitude positive 4.5 star, like Eta Carinae, is quite dim as seen from Earth, but it's clearly visible in a night sky without light pollution or clouds if you live anywhere south of the latitude of Cairo, Egypt. 30 degrees north latitude is the farthest north you can see this star. Now, listen up. Eta Carinae is currently up to something. It's been brightening again and is now brighter than at any time since 1864. It's a complex situation. Eta Carinae is really two stars, Eta Carinae A and Eta Carinae, what's your guess? Oh, B. There's a third star nearby that's also interacting with the double star's dynamics. Now, without looking, I'm guessing it's named Eta Carinae C. Good guess. Blown out into two incredibly massive globes of gas that are expanding at 20 million miles per hour, Eta Carinae is, without a doubt, one of the strangest looking stars you'll ever see. Remember, it's located at a great distance of 7,500 light-years away from us. And if anything had happened to Eta Carinae in the last 7,500 years, like going hypernova, we wouldn't be able to see it, because none of Eta Carinae's electromagnetic radiation would have gotten here yet. Astronomers are keeping a close watch on Eta Carinae because it can go hypernova at any time. Or maybe it already did 5,000 years ago, in which case we'd only have to wait another 2,500 years to see it. Yeah, like I'll put it in my planner. Now, from a list of over 30 likely candidate stars that might go supernova, Rho Cassiopeiae is many astronomers' choice. Another Greek letter, Rho, is the 17th letter in the Greek alphabet. It means that Rho Cassiopeiae is the star with the 17th brightest apparent magnitude in the constellation Cassiopeia. Yet Rho Cass, a nickname, is only one of 7 known yellow hypergiant stars in the Milky Way. It's another whopper. To be seen at magnitude 4.5 from a distance of about 10,000 light-years away, Rho Cass must be a very large star, a hypergiant. Placed where the Sun is, Rho Cass would encompass the orbit of Mars. But it's still yellow. It's not a red giant star. Red indicates a cooler surface temperature. Rho Cass, as huge as it is still as hot on its surface as our Sun, or even a little hotter. That can only mean two things. Deep inside its core, Rho Cass is fusing atoms much heavier than hydrogen or helium. Plus, Rho Cass is producing much more energy than a red giant star. In the year 2000, Rho Cass erupted massively. It brightened by 2 orders of magnitude as it ejected 10,000 times the mass of Earth into space at 4 times the speed of sound. Astronomers detected the signature of titanium oxide in this eruption. This means that Rho Cass is much closer to going supernova, or in this particular case, hypernova, than astronomers used to assume. Iron is just a few steps above titanium in the periodic table, and when iron forms, fusion stops and a star collapses. Rho Cass is really close, or more correctly, was really close. Because the eruption we saw in the year 2000 really happened 10,000 years before, many astronomers think Rho Cass has already gone hypernova, formed a black hole, and doesn't even exist anymore. Meanwhile, Betelgeuse caught everyone's attention not so long ago. The star, not the movie. It dimmed dramatically, appearing only 37% as bright as it usually is. Is it getting ready to go supernova? Betelgeuse is by far the brightest star in the whole sky, in infrared light. This is an important fact because it relates to Betelgeuse's status as a supernova candidate, as we shall soon see. Betelgeuse is also named Alpha Orionis, another Greek letter designation. So we should conclude that Betelgeuse is the brightest star in Orion, right? Wrong. It's the second brightest star in its constellation. Rigel, or Beta Orionis, is the brightest one in that region. Figure that one out. It may be because Betelgeuse is classified as a semi-regular variable star, which sounds kind of redundant to me. Its approximately 400-day cycle of pulsation changes its brightness by about 1 full magnitude, going from much brighter than a first magnitude star to closer to a second magnitude star. But never was Betelgeuse observed to dim so rapidly or so drastically as it did recently. So what's going on with it? Well, from late 2019 to mid-2020, Betelgeuse went through a period of substantial dimming during a mass ejection event. The world astronomy community jumped on the situation, and in the course of their investigations, they came up with some surprising new factual data on Betelgeuse. First, Betelgeuse is not as far away as we once thought. The new, more accurate distance for Betelgeuse is 548 light-years. That's 25% closer than previously measured. The second new fact, Betelgeuse's diameter has been reduced by the same percentage. The star is now known to be 25% smaller than previously believed. The cause of Betelgeuse's dramatic dimming was also determined. The giant star ejected a cloud of gas that contained magnesium. The cloud blocked a large portion of the light coming from Betelgeuse and made it appear visually much dimmer than it really was. Magnesium is not halfway to iron on the periodic table, which means Betelgeuse is not as far along on the path to a supernova as was suspected previously. When iron starts forming in the star, it means that this star is close to shutting down its fusion reactions. The next step is implosion. We aren't quite there yet with Betelgeuse. This star emits most of its energy as infrared light, and it also indicates that its core is most probably still burning helium, and not something that would greatly increase the amount of heat, like carbon for instance. Betelgeuse will still go supernova, but not for another 100,000 years. So you can cross it off your supernova list for the time being. And as for how to correctly pronounce Betelgeuse, you can say it any way you like. There are as many different pronunciations out there as there are people who think they know how to pronounce it correctly. Now, supernova 1987A caught astronomers off guard when it lit up the large Magellanic Cloud 100,000 plus light-years away from the Milky Way. That's when attention was turned to a similar star much closer to Earth, Rigel, in the constellation of Orion. Could Rigel surprise us and suddenly go supernova? There's something called the supernova problem that you should, probably know about because it may relate to Rigel going supernova or not. It seems that stars over 17 solar masses don't always go supernova. Recently, a red giant star simply vanished. Once again, it didn't go supernova, it disappeared. This had often been happening in computer simulations of supernovae, and now it finally occurred in real life. Rigel's mass is 21 solar masses. In other words, it's 21 times more massive than our Sun. So, will Rigel go supernova or simply vanish into a black hole that it'll create in its core? Astronomers and physicists continue their work of learning more about the dynamics of massive stars, scouring the sky for the next supernova in the Milky Way. Meanwhile, we can rest confident that we on Earth are in no danger from the harmful effects of nearby supernova explosions. We live in a nice, quiet, peaceful, stellar neighborhood, except for those Martians next door.
Most of those twinkling dots scattered across the night sky seem unreachable. But one of them is Betelgeuse, a star so enormous and nearby that you can see it with the naked eye. To find it, locate the first 3 big dots in the Orion's belt. A reddish star to the left is Betelgeuse. It's one of the brightest stars we can see from Earth. And it's just 640 light-years away, no big deal. Betelgeuse has a blue-white O-type star, which is one of the hottest types to exist. Betelgeuse was scorching hot, reaching temperatures of about 90,000 degrees Fahrenheit. Although that was back in the day, now it's an elderly star and it cooled down to just 5,800 degrees. Vacation weather. Blue-white stars are absolutely massive and burn incredibly bright because they have loads of hydrogen fuel. But they have a price to pay for this glory. They burn through their fuel super quickly. As they age, they transform into red giants. This is exactly what happened to Betelgeuse. It burned through its hydrogen and started burning helium instead. This caused its outer layers to puff up like a balloon, turning it into a red supergiant and making it one of the largest stars out there. Now it's stretching over 700 million miles in diameter. Now it's about 1,000 times bigger than our Sun. If Betelgeuse replaced it, it would swallow up Mercury, Venus, Earth, Mars, even Jupiter. And its atmosphere would almost reach Saturn. But something strange has been going on. Betelgeuse spinning way faster than it should for a star of its size. Huge stars like Betelgeuse are expected to rotate slowly, but it suddenly started spinning at a rate of about 3 miles per second. Thanks to powerful radio telescopes, Betelgeuse's orange-red surface can be seen in detail. That's how we learned that it often changes its brightness. Sometimes Betelgeuse shines super brightly and then gets very dim. This happens about every 400 days. And recently, a telescope called ALMA, which is made up of many antennas working together as one, showed that Betelgeuse's surface seems to be moving unevenly. It's like one side is coming towards us while the other is moving away. But all of it might be a trick of light. Betelgeuse isn't as smooth as our Sun. Instead, it's super chunky. Its surface is like a boiling cauldron. It's bubbling and churning incredibly fiercely. Imagine giant plumes of hot gas erupting from its core, reaching the surface and then vanishing back inside. And these bubbles are bigger not only than the Sun, but Earth's entire orbit around the Sun. These bubbles also rise and fall super quickly, even faster than a spacecraft. And maybe this tricks our telescopes into seeing it spin faster than it really does. Some astronomers also think that Betelgeuse could have swallowed up another star, and this gave it a spin boost. But these are all just theories. Things got even more complicated when Betelgeuse dimmed once again, this time in a pretty unexpected way. What's interesting, it was discovered using a weather satellite. A regular telescope had a hard time seeing Betelgeuse clearly because of Earth's atmosphere. So they used a satellite that normally watches Earth's weather, but can also take pictures of space. As we mentioned, it usually brightens and dims about every 400 days. But recently, it suddenly dimmed by 2.5 times more than ever before. This event got the name the Great Dimming. The first theory said that Betelgeuse cooled down and sneezed out a bunch of material, creating a massive dust cloud. This cloud blocked the view of the star, making it look much fainter than usual. They also noticed something strange happening to that dust. It started behaving differently, which might be a sign that something deep inside the star was causing trouble. Betelgeuse's brightening and dimming cycle now happens faster in just 200 days instead of 400. And to add to the mystery, in the spring of 2023, it started shining even brighter than it normally does at its peak. Why is this frightening? Because Betelgeuse might be preparing for its grand finale, and this wouldn't be very good for Earth. We might be on the verge of a supernova. When massive stars like Betelgeuse run out of fuel in their cores, they start burning different elements like carbon, oxygen, and silicon. Eventually, they end up with iron in their cores. At that moment, everything changes. Adding helium to iron doesn't produce energy like other reactions do. Instead, it sucks up energy. This causes the star's core to collapse, leading to what's called a core collapse supernova. A spectacular, breathtaking show. Supernovas are so bright that they can outshine entire galaxies. But a Betelgeuse supernova would be special. Because it's relatively close to us, it would be so bright that we could see it even during the day. When it happens, Betelgeuse will shine as brightly as a full moon, but all that light will be concentrated in one point. For about 2 months, it will be so bright that you could read a book just from the light of the supernova, even if you turned off all the city lights and had a clear sky. The idea of witnessing Betelgeuse explode as a supernova is truly thrilling. After all, the last time a star went supernova in our galaxy was way back in the time of Johannes Kepler, more than 4 centuries ago. That event, known as the SN 1604 or Kepler supernova, dazzled the sky for weeks. But don't get too excited yet. We're not sure when exactly it'll happen. One study says that the star might be in its carbon-burning phase. If we're near the end of that stage, then Betelgeuse might blow up very soon, during the next tens of years. But it's nearly impossible to determine because during that last phase, the star barely changes at all. Even though Betelgeuse is close enough for us to study its surface, we can't peek inside its core to see what's really happening with it. We might as well be at the beginning of the carbon-burning phase, and in that case, we might have to wait 1,000 more years before that cool supernova. Another study says that Betelgeuse might have less than 300 years of fuel left in its core. They say that Betelgeuse is known to expand and contract regularly, and its pulsation pattern hints that Betelgeuse is much larger than we previously thought. This would suggest that the star is further along in its life cycle and closer to going supernova. Other guesses come from observations of similar stars. For example, a star called VYCMA in our galaxy is thought to be closer to going supernova than Betelgeuse, and it's been dimming steadily over the past century, unlike the relatively stable Betelgeuse. If Betelgeuse was about to go supernova, it would dim steadily and very quickly. Also, historical records suggest that about 2,000 years ago, people saw Betelgeuse as yellow, not red. If that's the case, then we might be in its early last days after all. In other words, we have no idea whether it will go supernova tomorrow or in 1,000 years. We just gotta wait and see. But let's say it goes supernova tomorrow. What happens to us then? The 1987 supernova in the Large Magellanic Cloud showed that the effects from the supernova might be so strong we can sense it even from very far distances. The Large Magellanic Cloud is almost 170,000 light-years away, and we still detected the radiation. It's kinda hard to say exactly what the danger zone is. A rough estimate could be around 100 light-years. Luckily, Betelgeuse won't pose any danger to humans. It's hundreds of light-years away, and its supernova won't influence us in any way. We'll be able to enjoy its supernova beauty without any harm.